Water. How does the water cycle affect weather? Weather is a short-term state of the atmosphere, including temperature, humidity, precipitation, air pressure, wind, and visibility. These elements are affected by the energy received from the sun and the amount of water in the air. To understand what influences weather, then you need to understand the water cycle. The water cycle is a continuous movement of water between the atmosphere, the land, the oceans, and living things. In the water cycle, shown to the right, water is continuously being recycled between liquid, solid, and gaseous states. The water cycle involves the process of evaporation, condensation, and precipitation. Evaporation occurs when liquid water changes into water vapor, which is a gas. Condensation occurs when water vapor cools and changes from a gas to a liquid. A change in the amount of water vapor in the atmosphere affects humidity. Clouds and fog form through condensation of water vapor, so condensation also affects visibility. Precipitation occurs when rain, snow, sleet, or hail falls from the clouds onto the Earth's surface. Putting up a front. How do air masses affect weather? You have probably experienced the effects of air masses. One day is hot and humid, and the next day is cool and pleasant. The weather changes when the air masses move into your area. An air mass is a large volume of air in which temperature and moisture content are nearly the same throughout. An air mass forms when the air moves over a large region of the Earth, stays in one area for many days. The air gradually takes on the temperature and humidity of the land or water below it. When the air masses move, it brings these characteristics into new locations. Air masses can change temperature or humidity as they move into a new area. Where do fronts form? When two air masses meet, density differences usually keep them from mixing. A cool air mass is more dense than a warm air mass. The boundary, called a front, forms between air masses. For a front to form, one air mass must run into another air mass. The kind of front that forms depends on how these air masses move relative to each other and on their relative temperature and moisture content. Fronts result in a change in weather as they pass. They usually affect weather in the middle latitudes of Earth. Fronts do not often occur near the equator because air masses there do not have big temperature differences. Cold fronts form where cold air moves under warm air. Warm air is less dense than cold air. So a cold air mass that is moving quick can push up So a cold air mass that is moving can quickly push up a warm air mass. If the warm air is moist, clouds will form. Storms that form along a cold front are usually short-lived, but can move quickly and bring heavy rain or snow. Cooler weather follows a cold front. Warm fronts form where warm air moves over cold air. A warm front forms when warm air mass following a retreating cold air mass. The warm air rises over the cold air and its moisture condenses into clouds. Warm fronts often bring drizzly rain and are followed by warm, clear weather. Stationary fronts form where cold and warm air stop moving. In a stationary front, there's not enough wind for either the cold air mass or the warm air mass to keep it moving, so the two air masses remain in place. A stationary front can cause many days of unchanged weather, usually clear. Feeling the pressure. What are pressure systems and how do they interact? Areas of different air pressure cause changes in weather. In a high pressure system, air sinks slowly down. As the air nears the ground, it spreads out towards the areas of lower pressure. Most high pressure systems are large and change slowly. When a high pressure system stays in one location for a long time, an air mass may form. The air mass can be warm or cold, humid or dry. In a low pressure system, air rises, so has a lower air pressure than the areas around it. As the air in the center of a low pressure rises, it cools. The diagram below shows high pressure system. Sorry. The diagram below shows how a high pressure system can form a low pressure system. Surface air, shown by black arrows, move out away from high pressure centers. Air above the surface sinks and warms. The green arrows show how air swirls from a high pressure system into a low pressure system. In a low pressure system, the air rises and cools. How do different air pressure systems affect us? When air pressure differences are small, air doesn't move very much. If the air masses in one place remains in one place or moves slowly, the air takes on the temperature and humidity of the land or water beneath it. Such types of pressures has its own unique weather pattern. By keeping track of high and low pressure systems, scientists can predict the weather. High pressure systems produce clear weather. High pressure systems are areas where air sinks and moves outwards. The sinking air is denser than the surrounding air, and the pressure is higher. Cooler, denser air moves out of the center of the high pressure area towards areas of low pressure. As the air sinks, it gets warmer and absorbs moisture. Water droplets evaporate. Relative humidity decreases and clouds often disappear. High pressure systems generally bring clear skies and calm air or gentle breezes. Low pressure systems produce rainy weather. Low pressure systems have lower pressure than the surrounding areas. Air in low pressure systems come together or converges and rises. As the air in the center of a low pressure system rises, it cools and forms clouds and rain. The rising air in low pressure systems cause stormy weather. A low pressure system can develop wherever there is a center of low pressure. One place this often happens is along boundaries between air masses, between warm air masses and cold air masses. Rain often occurs at these boundaries or fronts. How do global wind patterns affect local weather? Winds are caused by unequal heating of the Earth's surface, which causes air pressure differences and can occur on a global or on a local scale. On a local scale, air pressure differences affect both wind speed and wind direction at a location. On a global level, there's an overall movement of surface air from the poles towards the equator. The heated air at the equator rises and forms a low pressure belt. Cold air near the poles sinks and creates a high pressure belt. Because air moves from an area of high pressure to areas of low pressure, it moves from the poles to the equator. At high altitudes, warmed air circles back towards the poles. Temperature and pressure differences on the Earth's surface also create regional wind belts. Winds of these belts curve to the east or west as they blow due to Earth's rotation. The curving of the winds is called the Coriolis effect. Winds would flow in a straight line if the Earth did not rotate. Winds bring air masses of different temperatures and moisture content to a region. How do jet streams affect weather? Long distant winds that travel above global winds for thousands of kilometers are called jet streams. Air moves jet streams with a speed of at least 92 kilometers per hour and often are greater than 180 kilometers per hour. Like global and local winds, jet streams form because Earth's surface is heated unevenly. They flow in a wavy pattern from the west to the east. Each hemisphere usually has two main jet streams, a polar jet stream and a subtropical jet stream. The polar jet stream flows closer to the poles in the summer than in the winter. Jet streams can affect temperatures. For example, a polar jet stream can pull cold air down from Canada into the United States and pull warm air up toward Canada. Jet streams also affect precipitation patterns. Strong winds tend to form along jet streams. Scientists must know where the jet stream is flowing to make accurate predictions.